ICSE Class 10 Physics Semester 2 Sample Paper Section B Solved. Hello my Class 10 students. This video is the solution of Section B of the Semester 2 Physics Sample Paper of ICSE Class 10, which is supposed to be held in March 2022. In this video, we will be solving Section 2. We have already solved Section A and it has been posted on YouTube already. So you can see the link somewhere on the right corner. You can click on that to see the solution of Section A. Now let us come to Section B. Section B is consisting of question number 2, 3, 4, 5, which means there are 4 questions, and out of these 4 questions we will have to solve any 3 questions. Each question is of 10 marks. So solving 3 questions will take care of 30 marks. Section A is 10 marks. What I want you to do is pause the video when you can and solve the questions on your own and then check up with my solutions. Okay? So shall we begin? Our section B, question 2, first subpart has A and B. Calculate the total resistance across AB. Now point A and B is here. We have this branch over here having these 2 resistors in series. So I'll call them as RS. And this 8 ohm is in parallel with this RS. Okay, so your RS is going to be 3 plus 5, which is 8 ohms, and these 2 are going to be in parallel, so I'll call this as RP. So we will say RS and 8 ohms are in parallel. Therefore, 1 upon RP will be equal to 1 upon RS plus 1 upon 8, which is 1 upon 8 plus 1 upon 8, which is going to be 2 upon 8, which is 1 upon 4, and therefore RP, which is the equivalent resistance between AB, is going to be 4 ohms. And that is our answer. Part B says if a cell of EMF 2.4 volt with a negligible internal resistance, means small r equal to 0, is connected across this AB, then calculate the current drawn from the cell. Now in this case, they are telling you that a cell is connected across AB, and this cell has EMF equal to 2.4 volts. Internal resistance is 0, and we know that V is equal to IR by Ohm's law. And so therefore your I will be equal to V upon R, means E upon R plus R. Now we have EMF 2.4 volts. This R is the external resistance between A and B, which turned out to be 4 ohms, and plus internal resistance is 0. So you could say that it is 24 upon 4 into 10. So 4 ones and 4 sixes. So we will have 0.6 ampere. You could either use this method, or you could say V is equal to IR by Ohm's law, and therefore I is equal to V upon R. Why did I say V upon R? Because internal resistance is 0, then your EMF is equal to V, so that is 2.4 upon the resistance in the circuit is this resistance, which is 4 ohms. It will still come to 0.6 ampere. And that is our answer B. Question 2, second part, has A and B again, which will absorb more heat, 10 grams of ice at 0 degrees C or 10 grams of water at 0 degrees C. Now 10 grams of ice at 0 degrees C is going to become 10 grams of water at 0 degrees C. And this is the change of state. So the heat absorbed by ice to become 10 grams of water at 0 degrees C, this heat will be mass into latent heat of fusion. So the mass is 10 grams multiplied by latent heat of fusion is 336 joule per gram, and this gets cancelled and you will have 3360 joules. This much is the heat required by 10 grams of ice at 0 degrees C to become 10 grams of water. So we have to say that therefore 10 grams of ice will absorb 3360 joules heat energy more than 10 grams of water at 0 degrees C, comma, to become, what is it going to become? 10 grams of ice is going to become 10 grams of water at 0 degrees C. And that is our answer. B part. For the same mass of ice, that means your 10 grams of ice, and ice cold water means water at 0 degrees C. Why does ice produce more cooling than ice cold water? Now more cooling will be because ice is going to absorb 3360 joules of energy more. So we will say as 10 grams of ice at 0 degrees C absorbs 3360 joules heat energy more than 10 grams of water at 0 degrees C, comma, to become 10 grams of water at 0 degrees C. We are just repeating the same statement that we wrote earlier, and then we will say this additional heat extracted by 10 gram of ice at 0 degrees C produces more cooling effect than ice cold water. Okay, let us come to the third part. The diagram below shows an insulated copper wire wound around a hollow cardboard cylindrical tube. Answer the following questions. Now, when the copper wire is wound around the hollow cardboard cylindrical tube, that becomes a solenoid. So these are the questions on solenoid. What are the magnetic poles at A and B when the key is closed? When the key is closed, the current is going to flow like so. So when the current is going over and under over here, you have to look from here. And when you look from here, it is going to go anti-clockwise. So A is going to be north polarity and B is going to go look at the direction of the current here, and if you look from here it is going clockwise, so it is going to be south. So what are the magnetic poles? You will say A is north pole and B is south pole. State 2 ways to increase the strength of the magnetic field in this coil without changing the coil. Now, if we don't change the coil, that means we cannot increase the number of turns. we cannot use the thicker wire. What will we have to do? We'll have to pass more current. So when we pass more current, what will we have to do? We have to use this rheostat. Okay, so we will use this rheostat to increase the current. So what are we going to say? Number one, by decreasing the resistance by using the rheostat so that the current in the circuit increases, comma, increasing the strength of the magnetic field. This is the first method. And the second method will be, now we can add one more cell over here because they are saying that do not change the coil. So we can add one more cell or we can insert a soft iron core here. Okay, so I think rather than adding one more cell, I will insert a soft iron core inside the hollow cylinder. So we will say by placing a soft iron core in the hollow cylinder. Okay, so that is how we finish our answer A and B. Now, what are they saying in the C part? If we place a soft bar at the center of the hollow cardboard and replace the DC source by AC source, then will it attract soft iron pins towards itself when the current is flowing through the coil? Now, they are saying that if we place a soft iron bar, which means that the second point could have been by adding one more cell to the circuit, we could have put that. But even if we write this, you will get your marks because this is a valid point. So by placing the soft iron core in the center of the hollow cardboard and we are replacing DC source by AC source. Now, what is going to happen with alternating current? The polarities are going to change. So if this is north, then it will become south, then it will become north, and then it will become south. So the magnetic property will be acquired by this solenoid. Only thing is that the polarity keeps reversing. So they are saying, will it attract? As long as there is magnetic property acquired by the solenoid, it will attract the soft iron pieces to itself. And the answer for this is yes. So we have finished with question number 2, that is 10 marks. Now we come to question number 3. In question number 3, first part, the diagram shows the cooling curve of 200 grams of water and the heat is extracted at the rate of 10 joule per second. Now heat is extracted, which means it is the power. Alright, power has been given to us 100 joule per second. Now from 80 degrees, the substance is cooling to 0 degrees C and the time it has taken is 640 seconds. And then from B to C, this is at 0 degrees C, means there is no change in temperature. So this is the change of state. Okay, and this AB is showing change in temperature. Now they are asking us calculate the specific heat capacity of water. The mass is given as 200 grams. So I will write here mass equal to 200 grams and the rate of extraction, that is power, is given as 100 joule per second and we have time as 640 seconds. So power is equal to W upon T. Therefore, W will be equal to P into T. Now W is the work done, which means it is energy. So the energy given out by this water from being cooled from 80 to 0 degrees C will be its power into time, which is 100 joule per second multiplied by 640 seconds. So seconds gets cancelled and we have 64 and these 3 zeros. This much is the heat liberated by water. Now in order to use formula for specific heat capacity, we will say Q, that is the heat energy liberated or given out, is mc delta T. Alright, the value of heat energy is 64,000 joules. Mass is 200 gram multiplied by C multiplied by this C is the specific heat capacity multiplied by delta T is from 80 to 0. So that is our 80 degrees C. So your C will be equal to 64,000 joules upon 200 gram into 80 degrees C. So let us cancel the 3 zeros like so. 8 ones and 8 eights and 2 ones and 2 fours. So this C means SHC of water. SHC means specific heat capacity of water will be equal to 4 joule per gram per degree C, or you can write it as 4 joule per gram per Kelvin. And this is our answer A. For B, heat released in region BC. Now, how much is the heat released in BC? So, for our B, your Q is going to be equal to P into T. How much is the time for this? Now, if we call this initial time as T1, then we will call this as T2. Our power, that is rate of heat extraction, is joule per second multiplied by, here it is 1312 minus 640, those many seconds. So you will have 100 joule per second multiplied by here 672 seconds. Now these seconds and seconds get cancelled and we have 67200 joules, and that is the energy which is released in region B. So we will write over here heat in BC. Okay, or you can write this full statement later on and that will be your answer statement. Question 3, second part A. Observe the diagram given below and state whether the bulb will glow or not when we switch on K. Now K is the key, it is open key. When we close it, there will be the complete continuous path. And so from the live, we will have the current flowing through the circuit and they are asking you, will it glow or no? So your A answer will be bulb glows or bulb will glow, as it will be a closed circuit. Is it safe to handle the bulb when it is switched off? Now, if it is switched off, your part B says when it is switched off, the key over here is going to be open. So the bulb will get switched off. But will it be safe to handle? No, because the bulb is still connected to the live and so it will be at a higher PD. So we are going to say no, it will not be safe. C part says give the reason. The reason will be as the switch is in neutral, the bulb continues to be connected in the live wire at high potential. Anyone handling the bulb connected in live wire will get a, hence not safe. Now they should have asked one more question, how you can avoid. If it is not safe, then how you could have avoided. Then your answer would have been that this K, the switch, should have been in the live before the bulb. Okay, so that is the main important thing. Let us come to question 3, third part. Two metals A and B have specific heat capacities in the ratio 2:3, which means if I call the specific heat capacities, if I call them as Ca and Cb, then Ca is to Cb is equal to 2:3. If they are supplied the same amount of heat, which means the heat for A is equal to heat for B, then which metal piece will show greater rise in temperature? We know that our formula for the heat is Q is equal to mc delta T, correct? So if our QA and QB, if they are equal, then we will have mc delta T of metal A equal to mc delta T of metal B. Okay, now they are asking us which metal will show greater rise in temperature if their masses are the same, which means your mass of A and mass of B being equal, they will get cancelled, and we will have Ca into delta T of A will be equal to Cb into delta T of B. Okay, so we will have Ca upon Cb will be equal to delta Tb upon delta Ta. So you will see that we have brought Cb here and delta T this side. Okay, so when it changes the side, this multiplication becomes division. Now Ca upon Cb we know is 2:3. So we will say therefore 2 upon 3 is equal to delta Tb upon delta Ta. So 2:3 means the denominator is greater. So delta T of A is greater. So we will say therefore delta T of A is going to be greater than delta T of B. So which metal piece will show greater rise in temperature? It will be A. A shows greater rise in temperature. All right. Now, let us look at the B part. Which metal piece will have greater mass if the rise in temperature is the same for both the metals? Now, here what are they telling us? They are telling us that your delta T of A is the same as delta T of B. So we again start with heat for A is the same as heat for B. So we'll have mc delta T for A is the same as mc delta T for B. Now delta T of A and delta T of B, they are equal. So this delta T gets cancelled and we will have mass of A into C of A is equal to mass of B into C of B. So you will have Ca upon Cb will be equal to, we have taken the Cb this side, so mass of B remains here and mass of A comes here, so it will divide, and this is 2:3, so that will be mass of B upon mass of A. So you will see that denominator is greater, so mass of A is greater. So we will have A will have greater mass. Okay, and that is your answer B. Let us look at our C part. If the mass ratio of the metal A and metal B is 3:5, then calculate the ratio in which their temperature will rise. Now here again, remember your mass of A, if you call as 3m, then mass of B will be 5m. And we will do exactly the same. Both the metal pieces have the same heat energies. So you will have mc delta T of A will be equal to mc delta T of B. Okay, so your mass for the A metal is 3m into Ca into delta Ta will be equal to, for B, mass will be 5m into Cb into delta T of B, and that will give us getting cancelled. We will have 3 into Ca into delta Ta is equal to 5 into Cb into delta Tb. Now we are asked the temperature rise. So delta Ta upon delta Tb will be equal to, now we have kept delta Ta here and delta Tb, we are taking that side. So it is going to divide. Now in the numerator we will have 5 into Cb upon 3 into Ca. These two quantities have gone that side, so they will divide. So that will give us delta Ta upon delta Tb equal to 5 upon 3, and here it is Cb upon Ca. Our Ca upon Cb is 2 upon 3. So Cb upon Ca will be 3 upon 2. So 3 and 3 got cancelled and we will have 5 upon 2. The ratio of the temperature rise therefore will be delta T of A is to delta T of B, which is going to be the ratio of temperature rise, and that is equal to 5:2. And this is our answer C. Okay, now we have finished up to here. Let us look at D part. If the specific heat capacity of the metal A is this, then calculate the specific heat capacity of metal B. Now we know that Ca upon Cb is equal to 2 upon 3, and they are telling us that Ca is 0.26 joule per gram per degree C upon Cb. That will be 2 upon 3. So your Cb will be equal to, Cb comes here and 2 upon 3 comes this side. So it will be 0.26 multiplied by 3 upon 2. So 2 ones and 2 here will go 0.13 times. So you will have Cb equal to 13 3 is 39. So 0.39 joule per gram per degree C. Okay, so specific heat capacity of metal B, which is Cb, will be 0.39 joule per gram per degree C. And that is our answer B. Are we understanding how it is to be done? Now let us come to question number 4. First part. A. Which of the following graphs, A or B, shows free vibrations in vacuum? Now free vibrations in vacuum will have amplitude constant. Where is amplitude constant? Here you can see the amplitude is constant, but in graph B the amplitude is decreasing. Can you see that? It is decreasing. So it is going to be graph A. How did you come to this conclusion? We will say since in vacuum there is no resistive force offered to the motion of the particles, comma, there is no loss of energy and the amplitude remains the same. Okay, this is what happens in free vibrations. Okay, let us come to question 4, second part. State the Faraday's laws of electromagnetic induction. Now, this you can get straight from your text. I don't have to tell you how to write. B part. Name one electrical device which works on this principle, that is on electromagnetic induction, and your simple answer will be AC generator. Okay, so that is your answer B. Question 4, third subpart. The nucleus X19482 emits an alpha particle. What will be the atomic number of the daughter nucleus Y? So X is going to become Y, and alpha particle means helium 42. This is going to be emitted, and so the atomic number from 80, it will be 80 minus 2, so that will be 80. This is going to be our answer A. B. What will be the number of neutrons in the daughter nucleus Y? Now when helium particle is removed from here, it is going to become Y, which will be 82 minus 2, that is 80 will be the atomic number, and the mass number will be 194 minus 4, that will be 190. So the number of neutrons will be 190 minus 80, which is 110. So this is our answer B. Write the nuclear reaction showing the emission of this particle. So we write X 194.82, and it is going to emit alpha particle. It's going to become a Y, plus it will give out helium, which is mass number 4, atomic number 2, and so your Y will have the atomic mass number 194 minus 4, which is 190, and atomic number will be 82 minus 2, that will be 80. So this becomes our answer C. You don't have to circle these numbers, you can just write the numbers by themselves. Let us come to question number 5. Name the electrical appliance shown in this diagram. Now this one, can you see this wire over here connected? So this is the grip, this is the socket of the electric fuse. So it is going to be your electric fuse. Name the material of the wire used in this device. Now the wire that is used is the fuse wire. It is an alloy of lead and tin. C part. Name two important characteristics of this wire. Number one characteristic is it must have high resistivity, and second one, it must have low melting point. Let's come to the third part, define pitch. This again is a definition you can find in any of the textbooks. Let us move to B part. Two wires AB and CD of same length are stretched to the same amount. Which wire will produce the sound of greater pitch by plucking it? And give reason for the answer. Now both of these are stretched, but you will see that this one AB is the thin wire and we have CD, which is the thicker wire. And we know that the area of cross section, if it is less, then the pitch is inversely proportional to it. So thinner the wire, less area of cross section. So AB will have the greater pitch. So your answer B is going to be AB. So this is your answer B. Now they say that give reason for the answer in your C part. So you will say that AB has less area of cross section and has greater pitch as frequency is inversely proportional to the area of cross section. Into bracket radius. So because the radius is less, area of cross section is less, and because area of cross section is less, the frequency is more, and frequency is more, pitch is more. Okay, let us come to the third subpart of question 5. A. Why is water used as a coolant in radiators of a car? We will say that water has the highest specific heat capacity, which is equal to 4200 joule per kg per degree C. Hence, each kg of water extracts 4200 joules of heat energy from the heated car engine, comma, cooling it considerably without much rise in its own temperature. Hence, water is used as a coolant in radiators of a car. We come to the last bit, that is B. Name the radioactive isotope used to find the age of the fossil. Now the radioactive isotope that is used for this, we will say carbon 14, that is C14-6. This is the radioactive isotope used. Name the radioactive radiation which it emits. Now radioactive carbon emits beta particle. So it is beta radiation. Okay, so this is your answer A and this is your answer B. So we have finished with all the questions of our section B. So we finish with section B. We have question 2 to question 5. There are 4 questions, out of which you have to solve 3 questions. Okay, so that will give you 30 marks for our section B. Alright, section A I have already uploaded. The link will be somewhere at the beginning of this video. So study well, study sincerely, concentrate on our work. You have enough time for preparation for semester 2 examinations. I will be soon uploading the chemistry paper also. So keep looking out for that also. In the meantime, stay safe, stay healthy. Bye.